I will first explain the screening process in the Environmental Impact Assessment or EIA. Screening is the first stage of the EIA process. Its main purpose is to determine whether a proposed development project requires an EIA study and to identify the category of assessment needed based on the Malaysian Environmental Quality Prescribed Activities EIA Order 2015. For our project, which is the construction of a new road from Kampung Bukit Kor to Medan Jaya in Marang, Terengganu. The screening process determined that the project falls under the first schedule EIA because it's located near environmentally sensitive areas. The project is close to several rivers, namely Sungai Lubuk Mandi, Sungai Anak Ring, and Sungai Kerak. And it is also situated near residential areas and active mining area. Therefore, the NEIA study is required to identify potential environmental impacts and to ensure that appropriate mitigation measures are implemented before the project proceeds. Next, I will explain about the scoping process in the EIA. Scoping is the stage where the key environmental and social issues that may be affected by the project are identified. It helps define the boundaries of the study and ensures that the EIA focuses on the most significant impacts. For this road construction project, the scoping exercise identified several important environmental components that require detailed assessment. These include water quality, hydrology, ecology, land use, traffic, and socio-economic conditions. The study also identified environmentally sensitive sectors such as nearby rivers, residential areas, schools, and public facilities that may be affected by the project activities. By carrying out the scoping process, the EIA team can concentrate on the major issues, propose suitable mitigation measures, and develop an effective environmental management and monitoring program for the project.
Next is potential impact and pollution prevention and mitigation measure of land use. Potential impact of the proposed project may affect land use, infrastructure, and nearby community during the pre-construction, construction, and operational phase. Pre-construction phase, 7 private land lots, approximately 3 hectares, within the row will be acquired, resulting in the conversion of existing land use to infrastructure land. Next is construction phase. Land clearing, demolition of structure, and utility relocation work will be carried out. Temporary impacts such as dust, noise, and traffic congestion are expected during this phase. Next is operational phase. The project is expected to improve road connectivity, transportation efficiency, and accessibility while supporting future development and socio-economic growth in the surrounding area. Next is pollution mitigation and mitigation management pre-construction phase. During the pre-construction phase, land acquisition will be carried out in accordance with relevant regulation and project requirement. Fair compensation will be provided to affect landowners to ensure a smooth acquisition process. During the construction phase, all activity will be confined within the designated right of way to minimize disturbance to surrounding area. Encroachment into adjacent land will be prevented through proper site management, and disturbed area will be rehabilitated upon completion of the work. During the operational phase, regular inspection and maintenance of the road will be conducted to ensure safe, efficient, and long-term use of the infrastructure.
This slide explains the existing environment, impact assessment and mitigation measure, focusing on topography, soil erosion, and sedimentation. To begin with, the existing environment of the project area shows that the terrain is generally flat to undulating, ranging from 1 to 15 meters above mean sea level. The slope conditions are mostly gentle, where class 1 and 2 slope dominate at 95.63%. Meanwhile, class 3 slope make up 3.68% and class 4 slope only 0.1969%, indicating that the area is mostly low risk in terms of steepness. Next, for the potential impact on erosion and sedimentation, there is the significant difference between different project phase. Before construction, the soil loss is estimated at 0.51 tons per hectare per year, with a sediment yield of 118.91 tons per storm. However, during the construction phase, without any mitigation measure, the impact increased significantly, where soil loss rise to 1,664.10 tons per hectare per year, and sediment yield increased to 335.81 tons per storm. This shows that construction activities can greatly increase erosion if not controlled. With mitigation measure in place, the impact is greatly reduced. Soil loss dropped to 156.44 tons per hectare per year, and sediment yield reduced to 29.55 tons per storm, showing the effectiveness of environmental control measure. During the operation phase, the impact became minimal, with soil loss record at only 8.98 tons per hectare per year and sediment yield at 0.27 tons per storm. Finally, for pollution prevention and mitigation measure, during the construction phase, several control measures are implemented under LDP to M2 and BMPs. This include temporary earth drain, checks dam, silt fence, and silt traps to runoff management. In addition, erosion control methods such as water brozoring, stockpile covering, and wash troughs are used. Slope stabilization, sediment control, proper waterway crossing, and regular monitoring are also carried out. For the operation phase, no additional mitigation is required because most areas are already paved. However, existing terrain and slope stabilization measures must be properly maintained. In conclusion, while construction activities significantly increase erosion risk, proper mitigation measures effectively reduce the environmental impact to a much safer place.
Next, I will present the significant environmental impacts related to geology and soils, together with the proposed mitigation measure. During the construction phase, land clearing and earthwork may cause soil erosion and sedimentation, which can affect nearby drainage system and waterways. Slope cutting and filling activities may also increase the risk of slope instability and localized waterlogging. Although the project area has a low seismicity risk, construction vibration may affect loose soil condition. During the operational phase, surface erosion and small-scale slope failures may still occur, especially during heavy rainfall. Sediment accumulation may also block drainage systems and affect road safety if proper maintenance is not carried out. To minimize this impact, erosion and sediment control measures such as silt fences, sediment traps, hydroseeding, and proper drainage system should be implemented during construction. In addition, regular inspection, slope stabilization measures, and maintenance of vegetative cover and drainage system are essential to terms slope stability and the safety of road infrastructure. Certain measures are important to minimize geology and soil-related impacts and to support the sustainable development of the proposed project.
Pre-construction phase, first conduct site survey and hydrological assessment, design temporary drainage system and water management plan, install erosion and sediment control measures, silt trap, sediment basing. For construction phase, land clearing and excavation increase surface runoff and soil erosion. Sediment may enter river and stream, reducing water quality. Temporary blockage of waterway can cause localized flooding. For operational phase, road and paved surface increase stormwater runoff. Reduced infiltration may increase flood risk. Poor drainage maintenance can lead to flooding, erosion, and sedimentation. Pre-construction phase mitigation measure. First, install temporary drainage system before clearing. Construct erosion and sediment control measures, silt trap, sediment basing, and shade dam. Maintain vegetative buffer and stabilize exposed area to reduce erosion. For construction phase, mitigation measure regularly maintain sediment basing, silt trap, and drainage channel. Stabilize stabilize exposed soil using mulching, geotextile, or temporary vegetation. Conduct continuous monitoring and avoid construction during heavy rainfall period. For operational pest mitigation measure, perform routine inspection and maintenance of drainage infrastructure, monitor riverbank and replant vegetation to prevent erosion, maintain sediment trap, and ensure compliance with drainage regulation.
Now I will present the water quality impact assessment and mitigation measures for this project. Water quality is one of the key environmental components because the project is located near Sungai Lubuk Mandi, Sungai Anak Ring and Sungai Kerak. During the pre-construction phase, minor impacts may occur due to site preparation and vegetation clearing, which can increase sediment runoff into nearby waterways. During the construction phase, the impacts are more significant. Earthworks and excavation activities may cause soil erosion and sedimentation, while runoff from stockpile areas, fuel spills, and improper waste management may degrade river water quality. During the operational phase, contaminants such as oil, grease, and litter from the road surfaces may be carried into nearby drains and rivers by stormwater runoff. To minimize the impact, several mitigation measures are proposed. These include installing silt traps and temporary drainage systems, implementing proper waste and stockpile management, providing spill control measures for fuel and chemicals, and carrying out regular water quality monitoring. In the operational phase, routine maintenance and cleaning of roadside drains are also important to ensure the long-term protection of nearby water resource. Overall, with proper mitigation and continuous monitoring, the impacts on water quality can be effectively controlled and maintained within acceptable environmental standards.
Impact assessment for traffic. Construction phase. Increase in heavy vehicle volume, material spillage and road damage, traffic congestion, vehicular emissions. Operational phase. Higher traffic volume, traffic emissions and noise, accident risk, lower level of service or loss for junctions, improve connectivity to major roads, and the mitigation measure for traffic. Construction phase. Implementation of a traffic management plan. Schedule the logistics and heavy vehicle movements outside of peak hours. Enforce speed limits at site. Ensure there are adequate warning, signage and lighting. Ensure workers abide by the traffic laws and regulations. Repair and make good all damaged roads after construction end. Operational phase. Proper traffic control and road safety procedures to be put in place. Carry out regular road maintenance. And the last one, impose speed limit.
So for this EIA project of road construction from Kampung Bukit Ko to Medan Jaya Marang, waste management has also been taken into consideration to comply with any statutory requirements required in the national policy and also state policy of Terengganu. So waste management, first thing, the local authority approved landfill is the Kampung Tertak Batu Sanitary Landfill located 5.3 kilometers south of the project alignment. This landfill is to help the managing waste and also to process or to dispose or to recover waste even efficiently, because that's the approved nearest landfill. Okay, so impact assessment of waste management is water pollution due to illegal disposal of putrefying wastes. So any sludge or any microbes will break down and turn into waste can enter the water body and enter into water pollution. Earth stockpiles may result in erosion and sedimentation. Municipal waste generated at site can attract pests, clog waterways, and also cause health issues and general malodor. So municipal waste generated during this construction can attract a lot of harmful pests, and then it also can create a sludge that could clog the waterways, and then generally it would just create just a very terrible odor for the people around, the citizens, or even the workers themselves. Scheduled wastes can result in land and water pollution. It is also toxic and hazardous. Motorists may indiscriminately dispose of wastes onto the road, and also scheduled waste may be generated from road maintenance or accidental slips. Pretty much self-explanatory about scheduled wastes and also the actions of the motorists that indiscriminately dispose wastes. They would just throw plastics or just throw some food packaging onto the road. So for the mitigate measures for this to work to mitigate this issue, we will have to establish proper stockpile areas, which is a biomass, earth, and etc. Dispose of residual wastes at the nearest local authority landfill. Manage scheduled wastes and properly dispose after at licensed facilities. Maintain regular housekeeping and also regular street cleaning and maintenance of drains. This to prevent any water pollution or any erosion or even any health issues. Mitigation measures in a big picture is to actually establish more proper areas to store hazardous materials and also for waste disposal. Waste disposal can be done at the nearest landfill, which is the Kampung Tatak Batu Sanitary. Schedule waste management and also proper disposal management. Regular housekeeping to ensure the construction site is safe and also clean, safe from hazards, and also we would say more proper storage for the construction, and also regular street cleaning and maintenance of drains to ensure cleanliness, to ensure proper management, and to ensure proper disposal method, and to establish proper management storage for the construction site, because the issue from the impact assessment has been affecting water and earth, so that the generally the construction site will be very dirty and also messy. So we have to come up with these mitigation measures to tackling the issues of impact assessment.
The biological assessment found that the project area mainly consists of secondary vegetation and disturbance habitat. Out of 46 flora species, 4 mammal species, 13 bird species, and 4 herpetofauna species were recorded within the study area. Among these, several wildlife species are classified as protected under Malaysia legislation. During the construction phase, the main impact on biological resources include vegetation loss due to land clearing, habitat destruction, and reduced habitat quality. Wildlife may also experience disturbance from construction, noise, vibration, artificial lighting, and increased human activity. In addition, habitat loss may lead to increased human-wildlife conflict and displacement of animal species from their natural habitat. To mitigate this impact, land clearing should be restricted to the designated road reserve area only. Phase clearing should be implemented, minimize habitat disturbance, proper management of biomass and topsoil should be also be carried to activate to facilitate future rehabilitation. For fauna protection, human hunting poaching activities must be strictly prohibit, and wildlife relocation should be conduct when necessary. Construction waste should be properly managed to prevent environmental contamination and disturbance wildlife. During the operational phase, the main impact include roadkill incident, continuing wildlife disturbance, and potential human-wildlife conflict. Therefore, habitat rehabilitation program should be implemented and wildlife warning signage should be installed at suitable location. In addition, active monitoring and management of wildlife population, particularly primates, should be conducted to reduce potential conflict.
Next, I will present the significant socio-economic impacts associated with the proposed road construction from Kampung Bukit Ko to Medan Jaya Marang, Terengganu. The socio-economic assessment focuses on the impacts that may affect the local community during the pre-construction, construction, and operational phase. During the pre-construction phase, land acquisition may be required for the road reserve. This could affect the landowners through the loss of land, property, or existing economic activities. In addition, local communities may have concerns regarding the compensation, project implementation, and also future development of plants. During the construction phase, several temporary impacts are expected. These include community disturbance due to the increased noise, dust, vibration, and traffic congestion. Public health and may also affected because of the construction vehicles and activities. However, this phase will also create employment opportunities and generate local business activities for community around there. There is also possibilities of temporary accessibility issues and increase of flood risk if drainage systems are disrupted. During the operational phase, the project is expected to provide significant positive socioeconomic benefits. This includes improved road connectivity, reduced travel time, enhanced the accessibility, and better transportation efficiency. The improved infrastructure may also stimulate the economic growth, increase property values, and support future development in the surrounding area. However, increased traffic volume may also contribute to accident risk or proper safety measures are not implemented. Overall, the project is expected to improve the quality of life of nearby communities through a better access to services, facilities, and economic opportunities. Next, I'm going to explain about the mitigation measures for the socio-economic impacts. First is pre-construction phase, where focuses on the land acquisition and compensation. During this phase, fair compensation is provided to the affected landowners while ensuring compliance with the Land Acquisition Act 1960. Stakeholder engagement activities are conducted to get the public feedback and address their concerns. And also, we provide a grievance management system is established to ensure the compliance and issues can be handled transparently and efficiently. These measures help build trust with the community before the construction begins. Next is construction phase. The construction phase is the second phase where the several environmental and social management measures are implemented. First is traffic management. A traffic management plan is prepared to minimize the disruption to the road users. Alternative access road routes are provided. Heavy vehicle movements are scheduled appropriately, and traffic congestion is expected to reduce as much as possible. Second is safety management. Safety is a priority throughout the construction. This includes installing safety signage and barriers, implementing an emergency response plan (ERP), ensuring safety vehicle operation, and providing welfare facilities for the workers. Third is nuisance control. To reduce the environmental disturbances, water spraying is carried out for the dust suppression, noise control measures are implemented, and construction equipment is regularly maintained to minimize the pollution and disturbances. Fourth is community relation. A strong communication with the local community is maintained through the public consultant, community engagement programs, complaint management system, and regular information dissemination regarding the project activities. Lastly, employment and local economy. The project also support the socio-economic development by the prioritizing local employment opportunities, supporting the local businesses, encouraging local contractor participation, and providing skill development opportunities for the community members. Next is operational phase. After the construction is completed, the project enters the operational phase. First is road safety. Road safety measures include proper road signage, adequate the street lighting, speed limit enforcement, and regular road safety audits. These initiatives help to ensure the safe travel conditions to all road users. Second is maintenance. Routine road maintenance is conducted to preserve the infrastructure quality. Drainage systems are inspected regularly to prevent the flood, and continuous monitoring is carried out to identify the address potential issues promptly. In conclusion, this environmental framework ensures that environmental, social, and economic considerations are integrated throughout the project lifecycle by addressing the community concerns, enhancing safety, minimizing the environmental impacts, and supporting the development. And the project contributes to the sustainable and responsible infrastructure development. In this also, we expected some outcomes, which is improved public safety, smoother traffic flow, increased local employment and opportunities, sustainable community development, and lastly, better overall quality life for the residents.